Hey, hi. To run the project, what you have to do, you have to unzip your project folder, whatever I will be giving you, and then you have to go to your project folder. Inside your project folder, then you have to open CMD. You can open CMD by right clicking in empty space, and you can just click to open in terminal, or else what you can do, you can select this address bar, just select all path and remove it and type CMD and hit enter. Okay, and here you can type Python app.py. This is the one of the way. Second way is what you can do, you can download VS Code, just like I have this VS Visual Studio. So you can download the Visual Studio code, and then you can go to this file, and then go to your open folder, and then you have to choose your project folder. Okay, and then you have to type, go to your terminal section, and then click to new terminal, and here you have to type one command, same command, Python app.py. So this way, either you can run from command prompt or Visual Studio. It's up to you. I suggest go with VS Code. Basically, VS Code, with the VS Code you can able to see the codes as well, right? So that will be helpful to you. You can view the code, and you can open any file of your project folder, right? And it will give you a proper workshop system, right? So that will be very easy. And then once you run your project now, then it will give you one URL like this. So you just have to click this URL, and you just have to follow this, and it will redirect you at a website. So this is the website which we have created, a simple website as we have discussed, but I have made it as much I you can. Okay, and then you have to go to register your account, and then you have to go to login page, and whatever credential you have put it, you just have to log in it. Okay, once you log in, then it will redirect you to this live prediction page. Okay, so here is the, as we discussed, I'll be providing you two input source, like one will be column based, one will be file based, right? So here you can also directly upload a file, and you can check the prediction. Okay, so we'll see this part later. First we'll go for the algorithm part. Okay, and other thing. So in this project folder, basically there are certain folders are there, right? So in the database, basically database is there, like we have used SQLite database. And for dataset part, like as of now there is no dataset basically. Due to space, memory space, I have removed everything. So I have given you previously one Google Colab link, right? So from there you can just download the dataset, or you can directly download from link, right? You have the link. So then here is the model. So it is whatever algorithm we have used. So here is our list of those algorithm models, and there is a notebook folder. So if you go to notebook folder, there are two files are there. One is Jupyter notebook, one is Google Colab, and one is notebook, and one is HTML file. Okay, similarly, if we go to a static folder, all the files, static files are there, like images and all the template folder, all HTML files are there. In test data, I have given you some test data for for just testing purpose. Similarly, app.py and database. Okay, so let's go to main part, database part, algorithm part. So this is the algorithm part. Okay, so as you can see, this is the complete file, HTML file which I have given you, where we have used all the algorithms and we have trained the algorithms. Okay, so we have used almost 10 to 11 algorithms, and out of 10 to 11, one was the very accurate, which we have implemented in live prediction. Okay, which was our main goal. We will be create some ensemble model. So I have added some unique thing there. I'll tell you. Okay, so we'll go one by one. So here you can see, here we are just importing the library, and here also we are importing the library, as we are using sklearn, right, for machine learning, and matplotlib for plotting, seaborn for plotting, pandas for file processing. Okay, and we have used kaggle. Okay, kaggle. So these are the actually the dataset files. These are the actual files which is available in dataset for this number of days. Okay, and what we are doing, we are just here in this code. What we are doing, we are just accessing one by one the files using pandas, and we are just concatenating it, like we are just merging all files into one, so that we can directly access everything by a single variable. So what we have done, we have just made it combined into DF data frame, a single data frame. So this is a single data frame. So it has basically total 80 columns, so which is huge, right? So 80 numbers are used. So these are the column list which is there. Okay, So basically these are the very there are some very like unused columns as well. There are some unused columns as well. Like suppose there is an active column is there. Okay, so what they have done, they have just unnecessary added mean value of active, standard value of active, max value of active, minimum value of active, like that they have done. So so out of these 80, I don't think all 80s are useful. So we have done the feature engineering as well. So I'll tell you. So out of this 20, we have just found key only 20 are useful, remaining are not much useful. Okay. So this is the description of dataset key, how many columns and what are the minimum and maximum value. So see, basically dataset is very imbalanced. Imbalance means, see, if we go down, so if we check, okay, so there is almost uh, okay, almost 22 lakhs of entries are there for this binning. Binning means, I guess it's normal. So it's normal. They having 22 lakhs, or I think lakhs, right? Take a guys. Yeah, almost 22 lakhs. Okay, right? And remaining are very unbalanced, right? Just like 2 lakh. This is just 1.5 lakh. This is 1.2 lakh. This is 1.01 lakh. This is 79,000. And these are only 11 entries. These are 21 entries. This is 36. Okay, so it is very unbalanced. And there is no use of using 22 lakhs entries. Okay, because if we train the algorithm only 1 lakh 2 lakh data is enough. Okay, that is 1 lakh 2 lakh number of rows is still very good number of data set. Okay, we don't require this much of data, so we have done processing. Okay, we have just done the uh, for handling imbalanced data, we have done undersampling. Okay, because we already have huge amount data. Okay, so we know there is no case of doing oversampling. Okay, that won't it will all unnecessary increase the data set. Okay, right? And so, and also increase the algorithm training time. So that's why we have chosen undersampling. Okay, so this is the function which basically plot the columns histogram. So these are the main columns and the histogram. The okay, and this is the graphical representation of values of all classes. So we have almost 15 classes, like one is normal and remaining are types of attack, right? So as you can see, the graph of this normal attack, normal packet is almost very huge, right? So it's unnecessary, very noisy data, right? And remaining are very small in terms of number of count, right? So basically what exactly these columns are, okay, see, these columns is nothing but, see, in if you talk about networking, right? If you talk about network, suppose this is the network here, like suppose I'm sending you WhatsApp message on WhatsApp, right? Okay, this is you, this is me, right? I'm sending you a message on WhatsApp. So what will happen, it will go through internet. Okay, and how exactly it goes through internet, it goes in the form of packets, right? It just uh, send the data in form of packet. Whatever message I will be type, it will first encoded into packet, different packet, do some research key what is the packets. And every packet has their own what you can say format, or just google it key networking packet क्या बोलते हैं यार उसको, headers or something. Okay, so basically in college I have read this. You will yeah, this one. So every packet has their this data, key, length, service type, packets, and etc etc. Okay, so these columns is nothing but the information of these packets. Okay, every packets headers information. So this is nothing but the same. So almost 22 lakhs of packets are there, information, not 22, more than it's almost 30 lakhs. Okay, so this is the same. Okay, so this is the graph. So like it is like that. Okay, this is the graph of flow. There is a column flow duration. So this is the graph key how exactly flow duration column graph is there. Okay, and this is the pie chart for the same key class count, and this is the also same pie chart. Okay, and then here what we have done, we are doing the undersampling. We are just removing unnecessary number of noisy data, and we are just summarizing. Okay, so see, after undersampling, as you can see, all columns all classes are like like it's stable, right? Ki it is not ki ye bahut zyada hai, this is very large, these are the number of rows very large. It's very stable, right? Ki everything is in same count. So here you can see only this count is normal packets is around 80% of data, and now here you can see it is just 21% after undersampling. So this way we have done undersampling. Okay, and then here we are doing the label encoding. Label encoding means ki in data set it has the classes and names like begin, dos, like that. Okay, so we are just assigning numbers. Okay, that is label encoding. So here we are applying label encoding ki we are just assigning numbers to each, and then we are saving the label encoding. This is the correlation graph of our uh, data set. Okay, it shows basically ki, how every column is correlated with each other. Okay, just like this column ACG flag count is how much correlated with flow duration column. Just do some research, you will understood. Okay, and then we are just dividing the data into x and y part. X and y part means what? See, suppose this is my data set. Okay, so whatever 79 columns are there, okay, 79, that is my x part, right? That is input. And whatever class label is there, label means output, that is y. So we are just considering x as a input, x as an input, and y as a output. Okay, and then what we are doing, we are dividing data into training and testing part. We are just taking this as a training part like a x and y, and this as a testing part. So it will become x train, this will become y train, this will become x test, and this will become y test. Okay, and then what we will do to find the accuracy, what we generally do, suppose this is the algorithm. So okay, so what we do to suppose this is any algorithm, so to train the algorithm, what we do, we pass this input x train as well as y train. Okay, we tell algorithm ki what is input and what is output, so that algorithm internally do understanding ki what is input and output. Okay, and then once the training will done, then we provide the input only. That during the testing we don't provide the output, actual output, we just provide the input. Okay, then algorithm will make some prediction ki based on input data, it make the prediction. Okay, and we store the prediction, and we do compare ki actual output with the predicted output ki whether are same or not. If it is same or for based on true and false result, we generally use the calculate the accuracy. Okay, so this way we divide the data set into x and y and training and testing and do the calculation, accuracy calculation. Okay, so here we are doing the same thing, we are just calculating x and y. Okay, and here I have done basically a feature engineering with the help of random forest classifier. As I told you, it has 80 columns. Okay, and we can't take 80 columns input with this function, this form, right? We can't put 80 columns here, and user will not, you are not going to type 80 columns numbers and you are going to make the prediction, right? This will create a huge uh, even if it, to type 80 columns value, it will take almost 10 to 15 minutes, right? So that won't be allowing by your professor, right? So that's why we are done feature engineering with the help of random forest. We are just created object of random forest, and we have divided data into x train, y train, and then we have done the training, and then after that we are identifying the importance of feature important, like it will give the important uh, features, and then we are just creating a new data frame by selected feature. We are selecting 20 features, and this is the output of 20 features from dataset, right? Almost 80 columns are data removed because those are not useful. Even we see, even for this 20% data, the number of some columns are very important and some are like only 0.023%. Okay, and remaining like if you check here, it is just 0.0.1 importance. Okay, so almost this number of rows not useful for prediction as well as not impacting the prediction. That's why we have just removed and we have just kept 20%, 20 columns. Okay, so like that. And then again we are just based on selected feature, we are just calculating x and y and training and testing data, and just we are storing the data. Okay, so I'll be giving you these files. I have downloaded all the files. Okay, and then here we have created a function key. It basically, this function calculate the accuracy, training data accuracy, f1 score of training and testing, recall factor, precision, everything it count. Okay, and then first algorithm which we have used is decision tree. We have created the object of decision tree, passing the data and making the prediction, and the accuracy for decision tree is around 92%. Okay, so you will get all the accuracy is 91, f1 score is 42, recall is 43, like that. You will get the complete. You can put this complete screenshot into your report or all. Okay, and then we have tried SVM algorithm as well, as data set are very huge in size, right? So SVM algorithm was taking huge time. Almost I kept running my system for 6 hours, but it didn't work. So that's why I choose to escape the LSSPM algorithm. Okay, then I have to just random forest. So then random forest is also around very good percent, 90% accuracy, and then KNN. Random forest is giving very good accuracy on our data set. Okay, and we are. I'll tell you next. Okay, in assemble model we have it has very important role in assemble model. I'll tell you. Okay, then we have used KNN. I have used almost all machine learning algorithms, logistic regression. Yeah, so we have used logistic regression as well. Okay, so for ensemble model, okay, for ensemble we have used stacking technique. Generally people use voting technique, that is not much very accurate, but stacking is something very accurate. Okay, so what generally assemble model is, generally there are two types of ensemble model. In first type is voting. So in the voting, what we do generally, take algorithms. So like suppose this is algorithm 1, algorithm 2, algorithm 3. All algorithm will, whatever, whenever we will pass the data, every algorithm will make the prediction key this one. Every algorithm will say ki this is the normal packet. Suppose this algorithm says DOS attack, this algorithm says DOS attack. Okay, so what will happen, number of votes for DOS is more, so output will be more DOS. Okay, like that voting is work. But in ensemble, what exactly it work, it take the algorithm. Suppose this is the algorithm 1, this is the algorithm 2, this is the algorithm 3. Okay, and this consists one meta algorithm as well. Meta algorithm is boss algorithm kind of. Okay, so whenever we will pass the data, suppose we are passing the input data, so first it will go to all internal algorithms like algorithm 1, 2, 3, and all algorithm will make the output. It will predict. Algorithm 1 will predict, algorithm 2 will predict, algorithm 3 will predict, and these predicted data will goes to meta algorithm. Okay, and then meta model will make the prediction based on this algorithm output. Key, this is algorithm. So then based on this, it will make the prediction. See, first this algorithm will make the prediction, then this algorithm will make the prediction ki what should be the output. Okay, so this is the concept of staking. Okay, it is ensemble only, but this is the technique which you can say ki this is the novelty part which you have done. Other papers has not done this thing. Okay, so you can say ki you have done this part. This is a unique thing. Okay, so for metadata, we have used meta model. We have used random forest, as random forest is giving very good accuracy. So we have take random forest as a meta algorithm. Okay, so if you check the code, so as you can see, meta model is a random forest and rest are depending. Okay, so rest we have used four algorithms in our hybrid model, and we are taking meta model as a fifth one as a random forest. Okay, and then we are training the algorithm, and you can see if you check the accuracy, almost it has given 99% accuracy, and precision is also very high. Okay, so compare, if you compare other algorithms, so this model has giving one of the best accuracy. Okay, and we have used this model in live prediction thing as well. Okay, so this is the live prediction uh, for hybrid one. Okay, so till yet machine learning part was done. Okay, and then here I am saving some testing data, based on selected feature, like just storing the data, key first row, first 10 row, last 10 row, middle 10 rows to make the prediction. So we are just storing the as if you download the data, it is almost 1 GB of file, right? And if you 1 GB of file open in Excel, it will get hang, right? So that's why what I have done, I have just separated the data like first 10 row, last 10 row, or middle row, first row, last row, like that, so that we can pass into here for prediction testing purpose. Okay, and this is a function for live prediction. This is the same key. Here we are just taking user input, here we are just taking manual input. Okay, and we are just making the prediction. And this next is deep learning part. This is also novelty thing which we have done. So for deep learning, basically generally used for image processing, but you can say for learning purpose you have tried with this data as well. So this is the keras is a main library for deep learning. So first, for training deep learning algorithm, we have to convert into categorical problem, just like here. Basically, we have 50 classes, so so whatever, suppose there is a row, okay, and the output is DOS attack, okay. So remaining we have to make it zero, and for the DOS class we have to make it one, okay. And remaining classes like beginning, port scan, we have to make them zero, okay. So like that it convert into categorical. And then here is a function for printing the accuracy. First we have tried with neural network, okay. We have just created a basic neural network, and for the neural network we have got very bad accuracy. Only 21% accuracy we have achieved, so which is very bad, okay. and and we have not got very much improvement in the epoch. What is epoch? In basically, see, in deep learning, uh, it train the algorithm based on epoch means what? Suppose there is a book. If you reading the book first time, okay, so how much you will understood? Just understood 10% part, right? But when you read the book second time, you will understood 20-30% part. When you do third time, you will understood 50% part. Like the same, okay, algorithm do training that number of times. That is epoch, okay. And then we are just testing. So we have got 21%. Okay, this is a graph. Similarly, then we have trained LSTM algorithm. LSTM is also one of the very famous algorithm of deep learning. And for LSTM, we have also used basic architecture. We have just randomly generated that. And for that accuracy, for LSTM is also giving very bad, only 30%. Basically, see, 47% is giving. Basically, see, deep learning will give very, always give very less accuracy on label data. This is label data, right? Categorical issue. Basically, deep learning is very useful for image classification. This is not image, right? Similarly, we have used JRU algorithm. For JRU, still we have got 53, somehow very medium level. And we have used auto encoder as well. So it as encoder was not working, it is just giving 10% accuracy, so it is very bad. So basically, encoder is generally used for text data. Text data means, suppose we want to predict sentimental score, comment, or text summarization, like that, okay. That's why, so we have not such problem. So whatever problem we had, the label data classification problem, that's why machine learning algorithm going very good accuracy and working very well. So this way we have trained the algorithm and all, algorithm and training part. And now let's go to the this uh, prediction. So as of now, let me pass some random values. So as you can, like that you can pass. So as of now, I'm providing random things, okay. I it's almost 22 minutes, right? So I'm just providing random thing, and then just have to click to check prediction, okay. And then it will, then you go down, then you will get a result. So it is saying it is a type of binning, okay. Similarly, suppose I have given you some data, right? If you go to your test data folder, so I have given you some data, like suppose you don't want to type the value of everything. So what you can do, you can create this kind of CSV file, but make sure ki the column should be same, like this, and you just have to provide the values, just like I've just scrapped from main data set, okay. And let me just pass this data. Let me select the path, okay, and go to choose file, and then here you can upload the file, like first spectral. This is the only one row of data frame CSV file, and then you can upload check the packet. So as you can see, the prediction is it is a class 2, and which is the DDoS, okay. Similarly, I have also given you output key, what exactly output. Suppose this is the first row, okay. So I have given you y value as well, key what is exactly output of this row. So if you open this, so the output was 2, okay. Similarly, I have given you some more testing files, like there's a file like a last x10, like the last 10 rows of inputs of from database. So these are the inputs. So as you can see, these are the inputs. Similarly, if you go down, so this is the output, okay, what should be the output. So this is the outputs of that particular rows, okay. So if you go now to web page and upload the last 10 row, just like this, let me upload the last 10 rows. So and click to check prediction. So here you can see it will give the prediction key. So there was 10 rows, right? So it is giving output for each row, like it is a packet 1, packet 2, packet 3. It is giving the class index key, this is the index, and this is the value of that index, okay. And if you go to the actual output, so this is the actual output, like 4204101010 to 42041010. So yeah, so it is like that. It is almost very 90 plus percent accuracy. So it will always give correct prediction most of time. Rarely it will give wrong false prediction. So this way you can directly make the prediction from files, as well as you can make the prediction by providing manual input, okay. And this is a training file, okay. So now do let me know in case of any doubt or anything, okay. So your system is completed.
Thank you guys for watching my video. If you're new, then subscribe channel and share with your friend. Don't forget to like, comment and share. Thank you.